Welcome back to 5-Minute Chemistry. Today we are going to be talking about the formula weight and the number of atoms and molar mass and things related to compounds. So when it comes to compounds, we have to consider that we can write them with either molecular formula or empirical formula. So molecular formula is when we define exactly how many atoms of a certain element are in a specific molecule, versus the empirical formula, which only tells us about the ratio of elements in a certain compound. So the ratio of atoms, more specifically, in the certain compound. So not every compound actually has molecules, while originally Avogadro defined molecule as the smallest part a material can be divided into with keeping its chemical properties. Now we have a more strict definition of molecules, which we will go into detail later, but not every compound has molecules, so some compounds we can only describe with the empirical formula based on the ratio of the atoms in it. So the formula weight, nevertheless, we can use to talk about the weight of molecules. We just get whatever is in the formula and treat it as the specific number of atoms and add up the weights of the atoms that are in the formula. So for example, if it comes to potassium oxide, which is a compound that is not made up of molecules, we can still use this empirical formula of K2O, which actually only means that in this compound we have 2 times as many potassium atoms than oxygen atoms, but we can treat it as if we have 2 potassium atoms and 1 oxygen atom in one unit of this compound. So when we talk about the formula weight, we just add up the relative atomic weights of the atoms that compose this compound. So 2 times the relative atomic mass of potassium and 1 times the relative atomic mass of oxygen will be used here. If we are talking about molecules, in that case, we actually can specify the atoms in the molecule. And if you have a large sample, you will still use the relative atomic masses or standard atomic weights in more general cases. So you are talking about large sample of molecules. The different nucleides in it will probably be the same as you would get for the standard atomic weight. So you can use the standard atomic weight, but there are ways to measure the mass of individual molecules. So in that case, you can see what specific nucleides are making up that specific molecule. And in that case, the molecule weight can be calculated as the sum of the atomic masses of the atoms that made up that specific molecule. When it comes to the Avogadro numbers relationship to formula, we can just say that the unit we specify with the formula, we have to have 6.022, etc. times 10 to the 23 pieces of that unit to have 1 mole. So if we have 1 mole of potassium sulfate, for which the empirical formula is K2SO4, then we can say that because it's 1 mole, so for potassium, 1 mole of potassium sulfate contains 1 times 2 moles of potassium, which is 1.2 times 10 to the 24 pieces of potassium atom. For sulfur, on the other hand, we have only 1 sulfur atom in this empirical formula, so 1 mole of potassium sulfate will contain 1 mole of sulfur. So that is 6.0 times 10 to the 23 pieces of potassium atoms. And for the oxygen, we have 4 oxygen atoms in this empirical formula. So for 1 mole of potassium sulfate, we will have 1 times 4 mole oxygen, which is 2.4 times 10 to the 24 pieces of oxygen atoms. So this way we can use the empirical formula to talk about moles in the case of compounds which actually don't contain molecules, just based on the unit specified by this formula. And when it comes to the molar mass of compounds, we will use the same method here. So use the formula and add up the molar masses of atoms. So because in 1 mole of potassium sulfate we have 2 moles of potassium atoms, we will get the molar mass of potassium, which is 39.10 gram per mole. And if you look at the periodic table, so the molar mass of an element will be the same as the standard atomic weight of the atom of that element. So for potassium, standard atomic weight would be 39.10. and therefore the molar mass is 39.10 gram per mole, and there are 2 moles in 1 mole of potassium sulfate, so we multiply it by 2. When it comes to sulfur, there is only 1 mole of sulfur in 1 mole of potassium sulfate, so we just multiply its molar mass, which is 32.06 gram per mole, by 1. And for oxygen, so in the formula we have 4 oxygen atoms. That means 1 mole potassium sulfate will have 4 moles of oxygen atoms. So for oxygen, we need to multiply oxygen's molar mass by 4. So it is going to be 4 times 16.00 gram per moles, and we just sum up the 3 elements this compound is made up of, and the potassium sulfate will have the molar mass of 158.26 gram per mole, and then we can use this in our calculations. Okay, so this is it for today, and I will see you tomorrow.